Yes, my dear students, let me start with another one more problem to explain eigenvalues and eigenvectors. So in this case, I have taken one symmetric matrix problem. Okay, so let me see, because I told you already that we are going to discuss about both symmetric and non-symmetric matrix, and inside we are going to discuss about our types of eigenvalues also. So the eigenvalues may be distinct, and any two eigenvalues will be same, or all the three eigenvalues will be same. Okay, so in that case, how to find out? There is a methodology and how to find out the eigenvectors. So that only we are going to discuss in all the remaining 4 or 5 classes. So let me start with this problem where a equal to, it is given as 8 minus 6 2. Okay, second row is minus 6 7 minus 4. Third row is 2 minus 4 and 3. To find the characteristic equation, we have determinant a minus lambda is equal to 0. So it is a determinant. Along the diagonal you need to subtract lambda. So it is 8 minus lambda minus 6 0, sorry 2, and minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda, which is equal to 0. And by shortcut method I am going to write that is equal to lambda cube minus s1 into lambda square plus s2 into lambda minus s3, where s1 is the sum of the diagonal elements. So it is equal to a11, a22, a33 by adding the leading diagonal elements. So it is 8 plus 7 plus 3, 18. Similarly, where s2 is nothing but sum of the minors of the leading diagonal elements. So how to find out the minors, that I told you already. How to find out for the first diagonal element, you have to delete the respective row and column. The remaining matrix will take, that is determinant value. So that's why I have written 7 minus 4 and 3. See that here I have written. Similarly, when you are taking the next leading diagonal element, you have to take the row and column, and the remaining you have to take. So that means that it is here 8 2 and 2 and 3. So that only I have written 8 2 and 2 3. And next one you see that here. The next one is, this is the leading diagonal element, that is the last leading diagonal element. So delete the respective row and column and take only the remaining, this remaining value. So one is 8 minus 6 and minus 6 7. So that only I have written. So always you remember that your minor you need to find out here. Now it is 7 into 3 21 minus of minus. It is, so it is minus 4 into minus 4 already plus 16. So we'll get 21 minus 16. So that only I have written 21 minus 16. Now it is 24 minus 4 and 56 minus 36. Okay, because this minus 6 into minus 6 will become plus 36. So I have written all and I calculated that value is equal to 45. Now the same way we have to go for finding the determinant value. So determinant value also, even though you have studied, I will explain you once again. So it is 8 minus 6 and 2 only we are going to make use of these three elements. So 8 into, you just delete this row and column and write the remaining 7 minus 4 3. Then for this element you take the determinant minus 6 minus 4 2 and 3. And for deleting this last one, minus 6 7 and 2 and minus 4. So add all the value. So it is 8 into 21 minus 16 and 6 into minus 18 plus 8 and 2 into 24 minus 14. Okay, so we'll get the answer as equal to 0. So there is no constant in this problem while you are finding out your characteristic equation. So you see that I have written, how I have written that, the characteristic equation. So it is lambda cube minus 18 lambda square plus 45 lambda. There is no constant term which is equal to 0. So simply speaking, by taking lambda outside, you will get one of the value of lambda is equal to 0. The remaining, it is a quadratic equation. Either you can factorize this equation or you can directly use by synthetic division. Applying here, I told you already that what are all the roots you need to try. So either you have to try plus 1 or minus 1, or plus 1 or minus 1, or you can go for plus 2 or minus 2, or plus 3 or minus 3. So among the 6, any one will definitely satisfy. So here I tried up to the 4th value, then plus 3 only it suits the problem. So I have substituted directly plus 3. So always you have to start your synthetic division with 0 here. So 1 plus 0, 1. Then 3, 1 into 3 is equal to 3. It is minus 15. Adding these two, then 3 into minus 15 is equal to minus 45. So I told you how can you select the suitable root for this equation is simply by writing, by making this end of the value as 0. Then only it is a suitable solution for this equation. So then the remaining is automatically how I have written. You see that lambda equal to 3 and lambda minus 15 equal to 0, lambda equal to 15. So already we found our first value is 0, lambda equal to 0. So therefore it is lambda 1 equal to 0, lambda 2 equal to 3 and lambda 3 is equal to 4. Okay. So lambda 3 equal to 15. Now to find the eigenvector, there is first eigenvector for the first eigenvalue. That is nothing but your first eigenvalue is lambda 1 equal to 0. So now for starting this one, we'll start to find out for lambda 1 equal to 0. Okay. So now I am going to substitute that 0 here. So along the diagonal I substituted 8 minus 0, 7 minus 0, 3 minus 0. The remaining elements I have written as it is. Now into x1, x2, x3 equal to 0, 0, 0. Because as I told you already, this is the eigenvector. Always it is a column vector. You should not write it as a row vector. If you are writing a row vector, you have to write it as a transpose. So you expand this one, you will get a linear system, and it is a system with a linear equation, and always the right side is 0, so it is a homogeneous equation. You will get the solution as usual, trivial solution or infinite number of solution. Your trivial solution is the 0 vector, so it never be an eigenvector. You should not write 0 vector as an eigenvector. So therefore, we are going to find out that infinite number of solutions by solving this equation. Okay. Now you need to analyze all the 3 equations, because I have shown you in the previous problem 2 equations are same. So here you analyze all the 3 equations are different. So for the cross roll method, cross roll multiplication, you can consider any 2. So I have, in the previous problem I consider first and second equation. Now in this problem I consider second and third equation. And as usual I told you cross multiplication also you can easily do that by taking always, if you are going to find out x1 value, then you take x2 coefficient, x3 coefficient. So I have written 7 minus 4 and 3 minus 6 and 2 next. Where you started, you end with it. Okay. So how can you calculate by that's cross roll multiplication? You have to multiply this and this way, and here also this way, and then this way. Okay. So your above value is related to x1, this is the x2, and this is x3. So I am finding out that only. See that how I have written, let it be here. And x1 divided by 21 minus, it is already minus 4 into minus 4, 16. So I have taken minus 16 by rule. Then 4 into 2, minus 4 into 2, minus 8. Then minus into minus plus 6 into 3 plus 18. Then x3 divided by minus 6 into minus 4, 24. Then 2 into 7, we have 14, minus 14. So let it be equal to k, say. So this k value, I told you, it's an arbitrary value. According to our choice, we have to make any choice of arbitrary value. And for k, so k is a constant here. So you got your x1 is equal to 5k, 10k and 10k. I substituted 5 for 1 by 5 for k, because of we have to make it as a very simple eigenvector. Numerically very simple eigenvector. So that's why I put k equal to 1 by 5. So we got the vector as 1, 2, 2. So x1 is equal to 1, 2, 2 for lambda 1 equal to 0. Now we'll go for the second eigenvalue. That is lambda 2 equal to 3. You have a minus 3i into x2 is equal to 0. And start to substitute along the diagonal. You subtract 3. So it is 8 minus 3, 7 minus 3, 3 minus 3. Remaining 2, all the elements are same. Into x1, x2, x3 is equal to 0. Now you write this. It is 5x1 minus 6x2 plus 2x3 is equal to 0. Minus 6x1 plus 4x2 minus 4x3 is equal to 0. 2x1 minus 4x2 plus 0 into x3 is equal to 0. Okay, so by using this, we have to go for now by cross rule multiplication again. You analyze this entire system. This is your linear system, as I told you already. So it is a linear system with the three equations. We need to solve this, and after that we have to find out the answer. So I consider only these two I have shown by the bracket. So these two equations I have considered. So by using these two equations, you write the coefficients, and where you are going to start to find out x1 means you start from x2 coefficient. So 4 minus 4 minus 4 0 minus x2, again where you started, you end with that. Okay. So this is again a cross root multiplication. I told you this value is related to x1, this is related to x2, and this is related to x3. Now you substitute the value. So what will you get? x1 divided by minus 4 into 0 0, and minus 4 into minus 4 it is plus 16, but by determinant of minor value it is minus 16. Then x2 divided by minus 8 minus 0, then x3 divided by 24 minus 8, and which is equal to k. I calculated all, so we got it as minus 16 minus 8 and 16, which is equal to k. Now what value got it? It is minus 2 minus 1 and 2, because k value I have taken it as 1 by 8, which is easily divisible by 8, so I have taken 1 by 8. Is it clear? So now we'll go for the third eigenvector, which is x3 for lambda 3 is equal to 15. So a minus 15I into lambda 3, that is lambda 3 is 15, into x3 is equal to 0. So x3 is also the same form of eigenvector. Along the diagonal I subtracted 15, 15, 15. So it is 8 minus 15, 7 minus 15, 3 minus 15. So you got all the values, numerical values, like the equations like this. 7x1 minus 6x2 plus 2x3 is equal to 0. Minus 6x1 minus 8x2 minus 4x3 is equal to 0. 2x1 minus 4x2 minus 12x3 is equal to 0. And based on that we are going to find out. So I have considered here any two equations we need to consider for cross root multiplication. So I consider first two equations. I started with by deleting the x1 coefficient. I started with the x2 coefficient. So minus 6 minus 8, 2 and minus 4 I have written. Minus 7 minus 6, then where you started you end with that. Okay. Now again here also it is a cross multiplication. So you need to apply here this arrow multiplications only. Then this calculation gives you x1, x2 and x3. So that one I have written here in the bottom. So your x1 divided by 24 plus 16, minus of minus plus 16. So then you have x2 divided by minus 12, then minus of minus 4 into minus 7 already to become plus, so it is minus 28. Then minus 7 into minus 8 is plus 56, then this is minus already, but by minor you will get another minus 36. So values are x1 divided by 40, x2 divided by minus 40 and x3 divided by 20, which is equal to k say. So k value you can give any choice of which is easily divisible, and by making the eigenvectors very simple vector you need to take. So I have taken 1 by 20, so your x3 is minus 2 and 1. Okay. Is it clear how to find out it? So we at last we got that all the three eigenvectors. You see that how it looks like because of distinct eigenvalues. For lambda 1 equal to 0, we got x1 equal to 1, 2, 2. And for lambda 2 equal to 3, we got x2 is equal to minus 2 minus 1, 2. And for lambda 3 equal to 15, we got the value as x3 is equal to 2 minus 2, 1. So this is this type of one is very what you can say, it is a symmetric matrix with all distinct eigenvalues. So the next classes we are going to see either by symmetric or non-symmetric, whether the eigenvalues are going to be repeated or let it be the distinct eigenvalues. We'll discuss in the next class. But I have given one homework for your practice. I have given all the answers also. So if you need to test yourself whether you are how much you are be thorough with this method of finding eigenvalues and eigenvectors. You just practice this problem and check your answer with this answer, and so that you make sure about your understanding. Okay, so thank you. These are all the 3 eigenvalues. So eigenvectors, 3 eigenvalues I have given. Okay, so in the next class we'll go for different few more problems. Thank you.